This is page 5 of grade 7 advanced post-course test. This is problem number 60. You install 404 feet of fencing along the perimeter of a rectangular yard. The width of the yard is 100 feet. What is the length of the yard? So we have this rectangle and the width is 100 feet. That means this distance is also 100 feet. We don't know what the length is. And the length is here. And it says you install around the perimeter. So perimeter equals 2L plus 2W. So now let's substitute. We know the perimeter is 404. We don't know what the length is, but we do know what the width is. So now we're going to solve for it. We're going to simplify 2L plus 200, and then we're going to isolate. 204 equals 2L divided by 2. You get 102 equals the length. So it's going to be 102 feet. Always remember that you're going to have to give a unit. So the length of the yard is 102. There you go. In a game, let's just see. In a game, you pilot a spaceship and gain a point for every asteroid you destroy. Sounds like the game Asteroid. The game ends when your ship is hit by an asteroid. You already have 94 points. Graph your possible final scores for the game. Graph the possible. Okay, so what is the game ends when your ship is hit by an asteroid? You already have 94 points. So, I mean, what is it going to be? Hits? I was going to do it. I was going to say I didn't know what my X and Y axis was going to be. So we really only have one axis, which is points. And we already have 94 points. Then we would have 95 points and 96 points. And yeah, see, they did this wrong. This is if a point for every asteroid. So you can only have whole points. So technically, it would just go ... out to there. But there's no way of writing that. You can't write that. They have this. This is incorrect. They have 94 closed circle with an arrow, but that's assuming that you can have 94.2, and that's not the case. This is wrong. This is really poor question. Final scores for the game would be something like this. Bad question. All right, now graph the solution of the inequality. We are going to start working with inequalities, which are less than, greater than, less than or equal to, or greater than or equal to. And we need to remember, well, not red, we need to remember that less than, greater than or less than, we're going to have an open circle because it's non-including. And if we have greater than or equal to or less than or equal to, we're going to have a closed circle. And that means we are going to include that boundary. So first thing to do is isolate the variable. We do it just like an equation. But now we have my solutions are less than 6. So I always show where 0 is. I show my solution. I'm going to have an open circle because if I plugged in 6, 6 is not less than 6, so it's not a solution. But I want to get it infinitely close to it, so that's why we have an open circle. So that is the solution. This is the graph to that solution. We'll divide by 3. X is less than 7, graphing it. 0, 7, open circle. My solutions are less than 7. So it looks like that. We're going to subtract 1. You have x over 4 is less than negative 1. We are not. We can multiply by 4. And we get x is less than -4. This time my 0 is here and my solution is to the left of 0. We still have an open circle and we're still going to the left. Okay, that wasn't that was the same direction, same open circle. I would have liked to have seen a couple other diagrams or examples. The probability of an event is 1/4 to describe the likelihood of the event. The likelihood is going to be, to me, the likelihood is going to be did I miss a different part of the question? 65. Let's see, 65. That's the answers. That was a weird course test. Here we go. Let's look at 65. Did I miss something in that question? 65. The probability, what is the likelihood of the event? That's an interesting question. The likelihood is 25%, or 1 in 4, right? 1 of every 4 is likely. So it says 7/50ths. I don't know. I don't understand why it would be 7/50ths. For 65. That's a weird question. Not sure. They're not doing a very good job. Use this table to find the relative frequency of spinning a 6 on a spinner. Number spun. So 6 is going to be 7 out of, we have, how much is total there? That's 20, that's 16, that's 14. That's going to be 30. So that's 7/50ths. That's 66. They reversed it. Isn't that interesting? 25, which is the likelihood, is 25% would be unlikely. That makes more sense. Yeah. If it's only 1 in 4, 25% is unlikely. Isn't that interesting? So relative frequency is 7/50ths. That's correct. And then 67, there are 11 green marbles, 12 orange marbles in a bag. You randomly choose one of the marbles. What is the probability of choosing a green marble? Is going to be 11 out of 23. We have successful outcomes out of possible outcomes. That is how you find probability. And 11/23. So they definitely mixed up 65, 66, and 67 on the answer key. The table shows the results of rolling a number cube 200 times. How does the experimental probability of rolling an odd number compare with the theoretical probability? All right, so theoretical is the mathematical of number cube 200. How does the experiment rolling an odd number? Well, on a number cube, there are 3 odd numbers out of 6 possible. So the probability should be theoretically 50%. That's the theoretical probability. Now, if we look at this in our experimental probability, we have 38 plus 30 plus 34 out of this total number. So that's 38 plus 25 plus 30 plus 41 plus 34 plus 32, which I think is 200 times. But we'll do the math real quick. So we're accurate. So let's do the numerator. 38 plus 30 plus 34 gives us 102. 102 out of, now let's do the denominator. So 38 plus 25 plus 30 plus 41 plus 34 plus 32. Yes, I know I could have done it better. That's 200. So 102, it's close. divided by 200, but it is not 50%, it is 51%. So the table shows how does the exponential roll. It's similar. It's very similar. Yeah, it's pretty much there. 50, the experimental probability is close to the theoretical. Yes. It's a good answer. Find the total number of possible outcomes when you select one color of wallpaper and one color of carpet. So when you have one color of carpet and total number. Oh, yeah. So it's 1, 2, 3, 4. So, sorry. 4 possibilities times 1, 2, 3, 4, 5 possibilities. So there are 20 combinations. And that's how you find combinations or possible outcomes is you take the number of choices times the number of choices, and there are 20 different combinations. You can do purple, 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 red, purple, yellow, purple, blue, purple, green, blue, purple, blue, red, blue, yellow, blue, 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 green, red, purple, red, 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 yellow, red, blue, red, green, green, purple, green, red, green, yellow, green, blue, green, green. So there are 5 for purple, 5, hence why we do 4 times 5. You roll a 6-sided number cube and flip a coin. What is the probability of rolling a number greater than 5 and flipping heads? Okay, so there's only 1 out of 6 numbers greater than 5, and there is a 1 out of 2 chance of flipping heads. So it is going to be 1 out of 12. What is the successful probability and successful? So 1 success out of 6 possible, 1 out of 2 possible. These are always assuming success. So you get 1 in 6. So it's 1 in 12 probability. Don't know if they want a percentage. Let's see if they want a percentage. Well, yeah, they say that. And let's do the math. Let's do 1 divided by 12 gives us 0.83. 0.83 repeating, which is not a percentage. That's the decimal. The percentage. Oh, sorry, I did that incorrectly. It is 0.083. If we go look at that again, 0.083. So as a percentage, move the decimal, that's 8.3 repeating percent of success. A couple plans to have 5 children. The gender of each child is equally likely. Design a simulation involving 113 trials that you can use to model the gender of the children. A couple plans to have 5 children. Design a simulation. You have our choices are boy/girl. So you don't have a dice, you don't have a 2-sided dice, but you do have a coin. So a coin could represent a boy/girl. And so if you flip 5 coins and you flip it, you're going to get, and let's say boy is heads, girl is tails. And so you could flip a coin and get this, and that could represent a boy, girl, 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 boy. And that would be one simulation. So you could do 113 of those 5 coin flips. That's one way of doing it. And that's it. That was a pretty quick video. So those problems were relatively nice and convenient. But probabilities are super important. So keep practicing that. And good luck.